In this video, we'll be going over the molarity homework on page 427, numbers 19, 20, and 21a. Number 19, suppose you want to dissolve 106 grams of sodium carbonate in enough water to make 6 liters of solution. First question, what is the molar mass of sodium carbonate? So to find the molar mass, we have to look up the masses of each element on the periodic table. We find that sodium is 22.99 grams per mole, and there's 2 of them, so we multiply that by 2, plus carbon is 12.01 grams per mole, there's only one of those, and oxygen is 16.00 grams per mole, times 3 of them, based on the subscript 3. We multiply that together, and get 105.99 grams per mole. So that's the answer to part 1. Part 2 says, what is the molarity of the solution? For part 2, we need the molarity equation. Molarity, represented by the uppercase M, equals moles of solute over liters of total solution. We have liters of solution up here, 6.00 liters, but we need the moles of the solute. So we start with the mass of the solute given, 106 grams of sodium carbonate. And we convert it to moles by using our molar mass, grams per 1 mole. And we decided in this last part that grams per mole is 105.99 grams of sodium carbonate per 1 mole. So that comes out to be about 1.00 mole sodium carbonate. So we plug our mole in on the top, we get molarity equals 1.00 mole sodium carbonate over 6.00 liters of solution. Calculate that. We get 1 divided by 6 equals 0.1666, repeating. Since we have 3 significant figures here for grams, 3 significant figures for liters for our volume, we only keep 3 significant figures, so we keep 0 as our placeholder and go 1, 6, and this last digit's our final one, so we're going to round it up to 7. And moles per liter we change to molar with a big M, so the solution is 0.67 molar Na2CO3, or sodium carbonate. And that is our answer for number 19. Number 20 says, suppose you want to produce 1 liter of 3.5 molar aqueous solution of sulfuric acid. What is the solute? What is the solvent? And how many grams of solute are needed to make the solution? Well, we look at what is dissolved. The thing that is dissolved is our solute. Also, we look at how the solution is labeled. We always name solutions by their solutes. So, in this case, it's a solution of sulfuric acid, so H2SO4 is our solute, because we have an aqueous solution of H2SO4. The aqueous tells us that the H2SO4 is dissolved in water. So if it's dissolved in water, water is our solvent. Finally, it wants to know how many grams of solute are needed to make the solution. There's 2 ways we can approach this problem. The first way is we can use the equation we used in the last problem, which is molarity equals moles of solute, which we now know are H2SO4, over liters of solution. We would then solve this equation for moles, so multiply both sides by liters, we get moles of H2SO4 equals the molarity times the volume in liters. And then you would just calculate that out. 3.50 molar or moles per liter times 1.00 liters gets us 3.5 moles of H2SO4. Then we would have to multiply that by its molar mass to get grams. So you have mole on the bottom, grams on top, H2SO4. Hydrogen, smaller mass, is 1.01, and there's two of them, so we have 2.02, plus sulfur, which is 32.07, plus oxygen, which is 16, and there's 4 of them, so 16 times 4, we get a molar mass of 98.09. So 98.09 grams per 1 mole. We multiply that by our 3.5 moles, and we get 343.315. When we look up top here, we only have 3 significant figures for both of our given values, so we stop at 3 significant figures for our answer. So the 315 gets dropped off here. Moles cancel, and I'm left with grams of H2SO4. And that's our answer for that problem. The other way we could have done this problem, we could have done it as a conversion problem. So instead of using the equation, we could have started with what we're given, which was the 1.0 liter. The 3.5 can become our conversion factor because molarity is 3.5 moles of solute per 1 liter. So we'd start with the 1 liter of solution. We want liter to cancel, so we put liter in the bottom. We want to go to moles, so this is where our molarity comes in. 3.50 moles per 1 liter, so moles of H2SO4 per 1 liter of solution. Liters of solution cancel. The question asked me for grams, so I'll put mole on the bottom, grams on top, H2SO4. And I already calculated the molar mass to be 98.09 grams per 1 mole. Moles cancel. And I'll still get the same answer of 343 grams of H2SO4. Either way works, it doesn't matter which way you do it, so pick the version that helps you best, that works for you, and that'll be fine. Just show all your units, show all your work, and it'll work out. Finally, question 21. It says, how many moles of NaOH are contained in 65.0 milliliters of 2.2 molar solution of NaOH in water? So NaOH is our solute because it's in water. It's the thing that's dissolved. Water would be our solvent. We start by looking at what we need to do here with milliliters and molarity. Molarity can get changed to moles per liter, and we can use that as a conversion factor, or we can use the equation as we did above. And so in order to use the 65.0 milliliters, we need to get milliliters to liters first. So if we start with the 65.0 milliliters, we want to get milliliters to liters. There's 1,000 milliliters to 1 liter. Then we want liters to cancel, so we put liters on the bottom, still liters of solution, and we put moles on top because we want moles of our solute. This is where our molarity comes into place, because it's essentially saying there's 2.20 moles of NaOH per 1 liter of solution. So if you write that in, 2.20 moles per 1 liter, then we can calculate it and get our final answer of the number of moles of NaOH. So we take 65 times 2.2 divided by 1,000. We get an answer of 0.143. 0.143. It's the three significant figures. Our given values are three significant figures, so that's right. And we give it units of moles of NaOH. And that's our answer. Again, if you wanted to do this with the equation, we would have molarity equals moles of NaOH per liters of solution, so volume in liters. In this case, we're solving for moles, so we need to multiply both sides by L. So we get mole NaOH equals molarity times the volume of solution in liters. So that equals the 2.20 moles that we had per liter, which is our molarity, and we multiply that by our volume, but we have to convert that volume to liters. So we take 65.0 milliliters, milliliters on the bottom, liters on top, we're dividing by 1,000. So we get 0.0650 liters. So we multiply by 0.0650 liters, and we get our answer of 0.143 moles NaOH. Either way works. And that's the end of this homework review.